Today we are going to discuss the topic about crawling and cogging of induction motor. The induction motor is an electric motor. It also named as asynchronous motor. The rotor is the motor has electrical current that generate torque from electromagnetic induction through the rotary magnetic field of the winding. The torque type of induction motor is wound type of squirrel cage motor. The main characteristic of motor are crawling and cogging. These are namely occurred because of the motor improper functioning, which means a motor runs less speed, otherwise don't use the load. The crawling and cogging of induction motor will not go faster because cogging characteristic of motor will not go faster at all. The growling characteristic of this motor will stop accelerating at a particular speed. This acceleration can be controlled through the torque of the motor. This is the diagram for crawling and cogging of induction motor. First, stator and stator slot and rotor slot and rotor slot between the round is called winding circuit, and center of the part is called rotor drum and shaft. Cogging. The torque caused by tooth harmonics, the stable operation at the synchronous speed caused by slot harmonics is called synchronous crawling, which is associated with vibration and noise. The stator and rotor of induction motor include a slot. The number of this slot should be not same because there is change of motor stop running because of the cogging characteristic. Due to this reason, slot of the rotor is not equal. There is no slot frequencies corresponding to harmonics frequency cause torque modulation. This slot are twice to maintain overlap and overall slot to decrease this problem. Methods to overcome cogging. There are different methods can be adapted to solve the cogging problem. First one is the number of slots within the stator as well as rotor should not equal. And second one is the arrangement of rotor slots skewing can be done in such a way that it can be angled through the rotation axis. Crawling. Crawling means that a torque caused by the tooth harmonics. The stable operation at synchronous speed caused slot harmonics is called synchronous crawling, which is associated with vibration and noises. And the voltage is applied to the induction motor contains harmonics, then the harmonics flexes are developed in the gap due to magnetics of the motor. This harmonics flex induced to the EMF and circulate harmonic current in the rotor winding. The harmonic current interact with the harmonic field and develop an additional harmonic torque. A common problem is with the seventh harmonics where it creates forward rotating torque field and 1/7 of synchronous speed. There will be maximum torque just below 1 divided by 7th synchronous speed ns. If this is high enough, the net torque produced and higher than torque produced due to fundamental frequency where at 1 divided by 7 ns slip is high. This maximum motor crawl at just below 1 divided by 7 ns. Reason for crawling of induction motor. It can be caused by the presence of space harmonics with the air gap flux. And next one is air gap harmonics can be occurred because uneven sharing of stator winding. The difference air gap reluctance can be occurred to the slot in stator and rotor. And avoid crawling of induction motor. The induction motor crawling less because it's high starting torque. So crawling and cogging cage rotor motor can be avoided through suitable selection of coil span and bending teeth of rotor slightly. So, crawling can be avoided or minimized to the selecting right combination of slots of stator and rotor. The crawling this motor can occur the portion of rated speed, whereas cogging of motor can occur if number of stator slot important several of rotor slot. Here, question for you: which motor the crawling and hogging? Thank you.